Alright, this video is going to be on combining like terms and distributive property. Feels like I misspelled something there, but let's go ahead and continue. We're going to start off with combining like terms. Now, when we combine like terms, it's basically we're combining or collecting like terms. And like I tell you in class, combining and collecting are putting things together that are the same. And basically what you're doing is you're adding and subtracting using War and Peace for those of you in my class. Now, excuse me. You can only combine things that are alike. If they're not alike, they're not alike. You've been actually combining like terms since you were young, like 2 plus 1. You know it's 3. You're combining positive 2 and positive 1. So let's go ahead and get started. So here's example number 1. We got negative 4x plus 3 minus 6x minus 10. And what we're doing is we're simplifying by combining like terms. These are called expressions. There's no equations, so they're not equations. And what we want to do is, the first way I'm going to teach you is to box your terms. So that's the first term, negative 4x. Remember, include the sign with the number behind it. Next term is positive 3. Next term is negative 6x. And the next term is negative 10. And now what we want to do is we want to look at, see if any are alike. Now we have variable terms. So we got negative 4x. And this term over here is also x's. That's negative 6x. And so when we combine x and x's, your answer is going to be an x's. Because x minus x is x. Apples minus apples is apples. And so now what we want to do is we want to subtract negative 4x minus 6x with the coefficient negative 4, negative 6. And those of you that are in my class, we use War and Peace. Are they at war? They're at peace? They're at peace, so our answer is going to be negative. And remember, when they're at peace, we keep the sign and we add the numbers, so you end up with negative 10x. So we combined all our x terms together, or collected them together. Now we have positive 3 and negative 10. Those are called constant terms. And they're called constant terms because they stay constant, they stay the same. Now, all constant terms are like terms. And so here we got 3 minus 10. We combine them, collecting, again, using War and Peace. Are they at war? They're at peace. They're at war. Who wins the war? The negatives. By how many? 7. And so you don't have any more like terms. You've actually combined and collected them. You have negative 10x and negative 7. Are those like terms? You always want to double check. No, one's a variable term, one's a constant. They're not alike. So your final answer is negative 10x minus 7. Now, sometimes the kids will write it backwards as negative 7 minus 10x. It's basically if you were to box your terms and you put them in a different order. And now those are equal. They're equivalent, I should say. But for our class, I want you to write the variable term in the front. All right, let's do another example. Here we got negative 5x squared plus 3x plus 6x minus 4x squared. I'm going to teach you kids another way to do this. The second way is, I'm sorry, this is a different one. I'm going to go ahead and box my terms. And now I'm going to look at the first term. I have x squares. And now let's take a look. Did I box any other x squares? Yes, I did. And so x squares minus x squares is going to give you x squares. And then you take your coefficient, which is the number that's multiplied by the variable. You got negative 5 and negative 4. War, peace. They're at peace. You keep the sign. And when they're at peace, you add the values. And so you end up with negative 9x when we combine those. Now, we also have x's there and x's. Now, some people might ask, well, what's the difference between x squared and x? Well, when you did exponents in 6th grade, you have 2 factors of x's in x squared. And here with the x, you only have 1 factor. And so x plus x is x. And you end up with 3 plus 6. Well, 3x plus 6x is the same thing as 9x. And it's positive. And you end up with negative 9x squared plus 9x. And then we want to check, can we combine those like terms? Well, we have x squares and x's. And so that's the final answer. You can write it backwards. But again, the answer key, you need to be able to tell if they are backwards or in a different order, I should say. Now, let's do another problem here. We got negative 5 plus 7y squared minus 6y plus 3 minus 8y squared. Now, let's go ahead and box all your terms. And let's start off with the negative 5 because that's first. And so let's go and look. Do we have any other constant? That's a constant. Yes, we have positive 3. So let's go ahead and simplify negative 5 plus 3. Are they at war or they're at peace? They're at war. Who wins the war? The negatives. And when they're at war, you subtract the numbers. You end up with -2. The next term in order is the y's. Any more y's? Well, here we have, I'm sorry, the next term is not, they're not y's, they're y squares. My apologies. So yes, we do. We have -8y squared. So we have to combine positive 7y squared, -8y squared. Y squared minus y squares are y squares. And then you use war and peace. Are they at war or peace? They're at war. Who wins the war? Negative. And again, when they're at war, you subtract. 8 minus 7 is 1. But we know we don't put the 1, right? Because when the coefficient is 1 or -1, we do not write it down. So we end up with -y squared. And then we have this 6y, -6y, I should say. And are there any other y's there? No. And so what happens if you don't have any other to combine? And what you do is you just bring it down, bring it down, bring it down. So we got -2 minus y squared minus 6y. But I'm going to go ahead and put them in order. If I were to box my terms, that has the highest exponent. So I'm going to put that in the front. The negative, because there's two factors of y times y is y squared. And the -6y with one factor of y goes next. And then your constant term, poor constant, always goes at the end. And so our final simplified expression with combining collecting like terms is -y squared minus 6y minus 2. All right, next thing we're going to go ahead and do is the distributive property. You get a distributive property when you were in 6th grade. But we're going to do it a little bit different. So let's go ahead and get started. Here we have -3 times the quantity of 5x minus 4. Now here, y'all, we're multiplying. Combining and collecting like terms we did earlier, it's adding and subtracting. But distributive property is multiplying. And so what we need to do is we need to distribute, and we're going to multiply -3 times every term in the parentheses. Again, that's -3 times the quantity of 5x minus 11. So I'm going to teach you two methods. The first method is using something called the area model. And so since that means -3 is going to be multiplied by every term, you draw a box, and you're going to put your -3 on the outside. And then you're going to put 5x your first term, and -4 is your second term. And you're going to go ahead and write them out and separate them. And then you multiply. -3 times 5x is -15x. -3 times -4. Negative times a negative is positive, and 3 times 4 is 12. And so we end up with -15x plus 12. And can we combine any like terms? No. We have a variable term with one factor of x, and we got a constant term of positive 12. And that's the final answer. Method number 2 is the way I use, and that's using something called where you distribute by drawing your arrows. Mr. Ty, our old teacher here, would teach it as... he would call it rocket launcher. And so here we got -3 times the quantity of 5x minus 4. Now, if you're well versed and you know that every term is going to be multiplied by, multiplied by -3, this way works beautiful, because what you do is every term in the inside, you're going to draw an arrow, like the first term is 5x, and you're going to multiply by -3. Remember your signs, though. You got to be careful. 5x times -3, one negative times a positive is a negative. 3 times 5 is 15. And you have one factor of x. Your next term inside the parentheses is negative. Oh, by the way, some people would just put -4 and they stop there. No, that's wrong. Because you have to multiply the -4 also by the -3. Everything in the parentheses gets multiplied by the factor on the outside. So -4 is your next term. And you're going to also multiply -4 times -3. Don't forget to include the signs. Negative times a negative is a positive. 4 times 3 is 12. And as you can see, we cannot simplify that, and you end up with the same answer in method number 1 and method number 2. Method 1 is actually very visual, and some kids that forget their signs should be using method number 1. Those of you that can see your factors and your terms right away should use number 2. All right, let me speed up here. Next example is 7 times the quantity of -9x plus 8. So every term in there, this is multiplying. So every term is going to be multiplied by number 7. Let's go ahead and use the area model. We're going to multiply 7 by the first term, which is -9x. And the positive 7. That's positive 7 times the second term, positive 8. What's 7 times -9x? Positive times a negative negative. 9 times 6 is 63. And you end up with -63x. And then you're going to multiply 7 times positive 8, which is positive 56. And I forgot to rewrite the answer, but that ends up being negative 63x plus 56. The other method, method number 2, which is just the rocket launcher method, it's the same thing, 7 times the quantity of negative 9x plus 8. So everything inside is going to be multiplied by 7. So the first term is negative 9x, and you're going to multiply by 7. Negative times positive, negative 9 times 7 is 63 times x. Then don't forget to multiply the second term, positive 8, by positive 7. Positive 8 times positive 7 is positive 56, because a positive times a positive is positive. And then you end up with negative 63x plus 56. And are any more like terms? No. And that's the final expression simplified. So I only did 2 examples of distributive property. I showed you 2 different methods. We're going to continue this week. Actually, we're going to start later on where we're going to have to use both methods, which is distribute and then collect like terms. And you always multiply before you add and subtract. So you're going to distribute before you combine like terms. Thank you for watching.